Check, check, test 1, 2. Check. I may begin. All right, thanks for coming in. We're talking about attack paths, threat models, and how to create them. And I'll introduce myself, which is awesome. I love doing that. My name is Wolfgang Goerlich. I am VP of Consulting. I'm a member of MySec. I do a bunch of weird things all the time. You guys may know me from other talks, like the Summer Blockbuster Threat Models of Future Past, which is all about a plucky group of consultants held together by EDM music. It's a blockbuster, you guys see it? And in a way, it's really a sequel to I Know What You Threat Model last summer, which was we were really proud of that one. Good tension, good drama. And of course, all this really culminates in the most popular talk that I've given that most people know about, which is How I Threat Model Your Mother. My daughter actually insisted I put that slide in because I never watch it. She helps me with the references, so I don't feel so lame. No, but I have. It's true, I have been talking about threat modeling a lot this year. I've been talking about it a lot because I care about it a lot. I've been talking about it a lot because I think in the MySec community we've been doing some very innovative things that I want to share with you today. Circle City Conference organizers, hear it up for them. They're doing a great job, right? First year, wonderful conference. When we were talking back and forth, I'm like, do you really want this talk? And they're like, yeah, we need a how-to. I'm like, this is more of like a workshop. They're like, no, you can do it as a talk. So we're going to try this. We're going to try this as a 4-hour workshop into a 50-minute talk. I'm going to walk through several threat models and point out some lessons learned. And after each threat model, I'll pause, we'll take a break, and I'll answer any questions instead of doing a Q&A at the end. I think that's probably the best way to do it. So 2 asks. 1, wait till I'm done with the threat model and say, hey, Q&A. And 2, if you would, we really want to focus on the process, because the process of threat modeling is what we're here to talk about, not necessarily the technology, not necessarily anyone giving control, but really, let's focus in on what we need to do to build a good threat model. All right, make sense? So first, let's wrap a little bit of context around threat modeling. Why do we do threat modeling? Why do we do anything in security? Ultimately, security from a risk perspective is all about managing that risk. And if you peel that layer down, right, you look at the fundamental formula, asset, vulnerability, threat. And you peel that a little bit further, you look at things like asset management, right, vulnerability management, our programs that are driving these things, and of course, threat management. And that is where we find threat modeling in a risk management program. It's part of the identifying, assessing, modeling, and managing process. And more importantly, too, as we build out these models, we can begin to say, okay, what does it really matter to our organization? What's the impact of this particular model? What's the impact of this particular threat? And how's it really going to impact us as opposed to something scary someone's heard about, something in this news? So why do we model from a threat management perspective? Well, obviously, to prepare for these threats and to minimize the impact. But that's just on the security side. Now, if you step back even one step further, and we look at the builders, not the breakers, we look at things like SDL, right, the security development lifecycle. And there again, threat modeling is a big component of that. We come up with requirements, come up with design, we threat model. How would this use case be abused? How would this particular feature be used against us? And that's the builders. What about the breakers? If you look at pen testing, right, P-TES itself, third step in pen testing, threat modeling. And it's like, great, we all want to know threat modeling. So a little while ago, maybe, I don't know, Jeremy, it was about 2 years ago now? About 2 years ago, we're like, yeah, threat modeling, it's everywhere, we need to know it. And we're like, okay, who knows how to do threat modeling? And you hear some great answers like, I do threat modeling, that's awesome, how do you do it? Well, it's really more of an ad hoc process. Okay, that's good. I do threat modeling, fantastic, tell me, what do you do? Well, I sit there and I figure out what's threatening me today, and I build, all right, that's not helping me. So as we were delving in, we really didn't find any good resources to do threat modeling. And that's what really drove this. And in quintessential MySec, this is very, very common. MySec is a security community. It's in Michigan. We call it an adhocracy because anyone wants to do anything is like, hey, I want to do something. And then a few people will go, yeah, me too. And we build something or do something crazy or jump out of an airplane. And so Jeremy Nielsen was like, hey, guys, threat modeling, this sounds great. Who's doing them? How does it work? And you could have heard a pin drop. No one knew. And at the time, I was a DevOps manager. At the time, I was responsible for development, security, and I was a security officer. And I'm like, that's awesome. No one knows how to do this. I want to know how to do this. Let's do this. So Jeremy and I started collaborating. We pulled up some different things. I already talked to you gentlemen in that you and I were talking about Stride, right? So we went, we're going to do Stride. Stride is awesome. It's documented, it's well known. It's an acronym for everything from spoofing identity down to elevation of privilege. And so we did Stride. And I took one of my applications. And what you basically do is you do a Stride on every single feature. And my application had like 40 features. And then 2 weeks later, I came out of the desert holding my plaque. I'm like, look, we have threats. And the developer's like, yeah, we got 2 new features. I didn't like Stride. Great concept, didn't like it. So then I heard about attack trees. I'm like, this is awesome. We'll map the path the attacker takes through the network as they go over here and go over there. And I got this great tree diagram. And it looked beautiful, and I could print it on my wall as like wallpaper. And yeah, I got that look when I tried to explain that to my ops guys. So I ran into some problems with threat modeling, and one of the main problems was communicating. I felt every time I was communicating these models, be it Stride or be it attack tree or whatever it is, that I was like this. Ladies and gentlemen, if you'll pardon me for a minute, we clearly have a vulnerability between this sponge and this marble. And if we invest, we will move that marble, and all will be well. I wasn't doing very good at communicating these models. It was very difficult for me. And worse, it took forever. At a time when all our networks are breached, right? At a time we're under fire constantly, I'm burning cycles on doing these threat models, and I did not like that either. I'm a very impatient person. If anyone hangs out with me for any amount of time, we're already moving on to something else. And it didn't give me any sort of reference as to what our true defenses were. How deep were our defenses? Could we dive in that pool? I don't know. I've got this great tree diagram. Where are we defended? I have no clue. And I couldn't communicate it out. I couldn't put in something like Excel. And I love Excel. For anyone who follows me on Twitter, I'm sorry. I had to tweet about Excel every once in a while because I love Excel. But just pause for a minute and appreciate the beauty of what we've done to IT people, folks. Over the past 10 years, we have trained IT people worldwide that if you give them an Excel file, they do it. It's a to-do list. It's beautiful. And I'm like, if I could just put my threat model in Excel, they would do the work. So yeah, we had problems, right? We had problems when Jeremy and I were trying to figure this out. It was too complex. It took too long. It was not actionable. And worst of all, it was not fun. And really, at the end of the day, isn't that what we all got into security for? Right? I mean, there's no lulls. There's no lulls in that. So at MySec, we started figuring it out. We started beating our head, trying to figure out different ways, different paths, different methods, and we came up with a thing called attack path. That's what I want to show you guys here today. This was our answer to the problem. It's still evolving. We've been doing it for about a year. We will walk through it. We'll do several of them, and we'll, talk about it and give it a try. I really want this session. You guys should all leave with at least one good idea about threat modeling, whether it's attack paths or whatever you're using in your environment. And really, that's behold on you when I stop and we pause and do the Q&A. But also, give us some feedback on what works and what doesn't. Effectively, attack paths are tactics, controls, and exercises in an Excel file, very simple. With those, we roll them up into something called abuse case. I'm not really going to go too deep into abuse cases today, other than to say it's what it matters to the business, what it matters to the attackers, what the path is, and what's the communication plan for driving behavior. If you guys have some time, you want to know more about that, hop on YouTube, hop on Iron Geek's site, look up the talk we gave at B-Side Chicago. So problem to solution, too complex. MySec attack path is dead simple. As a matter of fact, usually when I talk to someone on defense, this is what they complain. Well, it's too simple, Wolf. You're right. Attacks are complex, and we'll deal with that in a little bit. It can be done very quickly. Typically, these are done in about 1 or 2 hours. Oftentimes, we'll drag it out to 4 hours just to really explore the problem space. It has defined metrics. We'll talk about that in just a moment. And again, it's an Excel, it's a to-do list, it's action items, it's actionable. So with that, let's walk through several of these models, and we'll see what they look like. I'm going to whiteboard some things. I like Excel. I'm a manager. I'm not a graphic designer. I'm apologizing up front. These are my lovely graphics. Okay, imagine if you were. that we had a business with multiple locations, okay? Everyone has multiple locations, multiple branch offices. These locations are connected back to the data center, maybe over VLANs, maybe they're over different firewalls with VPNs. At some point in time, the attacker comes, and at some point in time, someone downloads a file, gets an email, gets infected. This particular piece of PDF malware that we're looking at will spread everything over, oh, you're not going to be able to see that. Okay, everything over one subnet. It will spread by talking to Windows servers. It will spread by infecting every single PDF that that piece of computer can get to. And what's interesting about that is then when they try and clean up, the minute people go back to work, they open up files off the file share, they get reinfected. Kind of a nasty piece of thing. So let's take a look at what that threat model looks like. We'll see how well you guys can read in the back. Probably not. I'll read it a little bit. So we'll break the common attack into several stages, right? Someone sends a malicious email. End user opens up that PDF. They leverage some Windows unpatched vulnerabilities and spreads throughout the network and enumerates Windows shares. Okay, so the key things here are, first off, breaking up the tactics into several stages and having good informed discussions with your people about what those stages mean and look like. I apologize, I just roll around a lot. Secondly, working top to bottom and telling that story to your IT folks, telling that story about what that breach looks like. And third, using very clear language, using language in these tactics that can be described to anyone in an IT function, director level, C-level, what have you. We're not talking about MSO whatever. We're not talking about some specific vulnerability or some specific MD5 hash. I know I'm going to drive you crazy on the camera. I apologize again. Causing a business interruption, something we can communicate. Fantastic. So this is common malware. It's a common occurrence, right? It happens everywhere. Of the different abuse cases, this is the one we see most often in VitalPoint SOC. Business relevance, very simple. We don't want to be down. Attacker objectives, very simple. They want to take us down or they want to join us to our network, their botnet network. We break that up into several stages. The stages don't really matter. These are the stages we use. Everything from external recon to achieve objective, but they can be flexible. They can be dynamic in telling that story. Also, you notice when I showed the first, there's only 4 of those stages. So we can collapse and expand as needed. This is one of the differences between a lot of traditional threat modeling is we can add stages to account for branches and account for different tactics. And the lessons we learned here going through this is keep it very tactical, right? Keep it not specific, but in language that can be communicated to anyone in the organization who has an IT background. Break it into stages and use those stages to drive the communication and to drive the discussion. And most importantly, whenever we do this one in a workshop, invariably, someone tries to overthink the attacker. They're like, well, that malware came from the Chinese, and they're out to get us, and they want our intellectual property, and they're pivoting. I'm like, no, dude. It's a bad PDF. It's spam. Don't overthink it. Honestly, it's not advanced. It's not persistent. It's just malware. So one of the common things that happens in this threat modeling, actually, if you're trying, especially if you're trying to do it in an hour, is people overthinking it. I noticed we had some of the same things happen in the earlier threat model talk today we were doing, because everyone's like, oh, well, it could be this, it could be that, and maybe they pivot, and maybe it's like, okay, it's just malware. We can do this. Okay, so that's the first example. Before I jump to the next example, any questions about that? Sweet. Okay. Let's talk a little bit about the insider threat. Another common one we see, right? Some stat said something like 60% of all attacks is insider threat. Sometimes those insider threats come looking at like normal, everyday people with purple shirts on who may have nicknames like Belt. And you got to be very careful because they look like normal people, but they're really red stickmen who are after your files and your SharePoints, and they're evil. So a very simple threat model for insider threat includes things like they're going to try and open up files, right? They're going to try and get to things they have access to and things they don't have access to. They're going to try perhaps to log into your account, right? Perhaps Belt here has all the access, and for whatever reason he loses his job, which would be a shame. and someone else in the team tries to log in as Belt to get those files. Someone devious who wears lockpicks. Anyways, so hypotheticals, right? So we may look for things like, hey, who's logged into disabled accounts? And how are they exfiltrating company data? Again, we're looking at this very high level. And another thing that's kind of interesting, once you start breaking up these attacks into high-level tactics, is each one of these things becomes an indicator of compromise, right? Our hypothetical insider threat probably isn't going to follow a run book. He's not going to check in and say, what's our procedure for exfiltrating data? I want to breach you, unfortunately. This should be better trained. This should be better security training now I'm thinking about it. But each one of these, it only takes one or two of these tactics, which become indicators of compromise in your security monitoring system, one or two of these tactics to fire off to start an investigation of that abuse case. One or two of these tactics to fire off, start an investigation of abuse case that allows the defense then to recognize that this insider threat is happening. They may not follow the entire path, but by keeping it high level and having enough granularity in there, it only takes a couple of those indicators to fire for us to win on the defense. It's another common occurrence, right? Business relevance, pretty simple. No matter who you are, no matter where you are, your business is making money off data. We need to protect that data. Attackers' objectives, pretty simple. Insider threat, they want to get stuff from you. We want to stop them. Again, we're looking at tactics, not specifics. We're looking at stages in attack. Just like in the last model, we didn't want to overthink the attacker. In this particular model, we don't want to overthink the tactics. Something as simple as opening a bunch of files that we don't have access to or logging into a disabled account is enough of an indicator of compromise when put into a threat model and communicated to our SOC to trigger off and to be investigatable and to be actionable. Questions on that one? I'm not going to give away any red tape. I'm going to keep them all for myself. I'm going to win all the swag. It's going to be awesome. All right, breach postmortem. So those first are just common things, right? We all get infected by malware. We all got an insider threat, one or two in our environment. It's just the way it goes. What happens if you do get breached, and how can you use threat modeling to do a postmortem on that breach? And then, now that you got that postmortem, to begin looking at remediation, begin looking at ways you can exercise. Let's do that next. Disclaimer, these are things that are scenarios we run through in the MySec workshops. This isn't an actual breach. There's no NDAs. You know, if you Google, did this really happen? It didn't. I'll tell you right now. I'll save you some time. But once upon a time, there's a hypothetical company that wanted to send payment processing data over the internet to a payment processor. And they said, great, we want to be secure. We all want to win. We want defense in depth because we all want to win. We want to have the right controls in the right place, and we need those blinky boxes. And here's what they built. I'm moving again, and they're not going to get me on camera. So we've got the payment processor, and he's sending files through a firewall with a WAF to that server. This payment processor is sending these files over SFTP, which means it's encrypted on the wire, very important. Also, another layer of protection is GPG, which means the files themselves are encrypted. To manage and maintain those files, we've got an HTTPS website that they log into, credentials, passwords rotating, right, all the normal things. To make sure no one compromises that website, we've got a lovely WAF that protects it, and because we're PCI and it has absolutely no defense for this scenario, we've got full disk encryption. And life is good. Until one day, there's a patch that needs to be applied. During a patch review process, IT ops is like, look, I'm trying to put this patch on. I'm having problems. Well, why are you having problems? Well, I don't know. It just doesn't come with the Russian language files. On my US server, really? Really? Huh. Needless to say, they were owned. Needless to say, they had to pay some money for cleanup. Needless to say, it was game over. At a very high level, I'm going to jump back. Here's what happened. That WAF, which was a fantastic WAF and was doing a great job, was turned off for maintenance and no one noticed. There just so happens to be a SQL injection vulnerability on this website that allowed them to get access to it and modify the website and install a backdoor. Oh, and by the way, what you don't see in this diagram is that they're running Apache as root. Always a good thing. But don't worry, right? We got GPG encryption. We're safe. Except they decided to keep the private keys on that server just in case. Yes, thank you. So what does that look like in an attack model? Well, if you take that path up and you break it down, it's like, hey, they started with some port scanning. They did some web page enumeration, right? They tried to log in over SSH. It's not something I mentioned here, but that was something else they found. They executed some malcode. They installed a remote shell. You see, we walk all the way down the path. Now, once you have this path, once you do this post-mortem, we can begin to do some actionable things with these models, such as doing tabletop exercises. Tabletop exercises, we take the path the security team has figured out, we pull in the IT guys, right? We pull in the firewall team, we sit around a round table. If you saw Belts talk, that was the key point, right? Key takeaway, we need a table. Tabletops don't work well without tables. And chairs. Now you just increased the budget. Make a mistake. So then we can start wrapping some controls around, right? Typical controls, detective controls. Can we see the attack? Preventative controls, can we prevent the attack? But we tie these controls to each tactic, which is key. How much visibility do we have into that attack path? How much preventive do we have into that attack path? And then we can go ahead and wrap some metrics around that too, right? So for detection, time-based, how long is it going to take us to detect? And for prevention, either it works or it doesn't. In a time-based scenario, doing these models, at first, we were like, oh yeah, just put it in time. And we're like, it's 15 minutes. And the other guy's like, no, it's a half hour. And the third person's like, yeah, it's going to take us a week. And that was just really painful. So one of the lessons learned we had here was in time-based, we look at very high-level things. Again, the whole concept of this model is to be high-level and simple. Is it hourly? Is it daily? Is it weekly, monthly, or quarterly? Very simple time windows. And then we can work back up, and really it doesn't matter if you guys can't see this what the controls are because it's all a moot point. But we can work back up and fill in the controls with the IT people that are applicable to those tactics. And we work back up for a reason. There's a couple different things at play here. One is just cognitive load theory, right? You know, cognitive load theory, the more decisions you make, the worse your decisions are. If you guys want a great example of that, think of the last time you had a meeting with 5 agenda items. You spent 40 minutes arguing over the first one, and the last 4 were like 10 minutes, and then 10 minutes for just talking. Cognitive load theory, right? The second thing is signal to noise. The closer we are to that objective, the less noise there is. The likelihood of someone trying to read our GPG keys, pretty low. Pretty high signal there that something bad has gone wrong. The likelihood of someone at the top of the path doing port scanning and trying to log in SSH, pretty high. It happens all the time, right? Anyone who's watching firewall, you see that constantly. So we leverage human psychology and we leverage what we know about true attacks to work backwards and fill in the controls and spend most of our time in those 2 hours focusing on the things that are going to drive the biggest benefit. 80-20 rule, Pareto principle. From this too, you can also look at some very simple defense and death metrics. We've got 14 tactics, and we can detect 9 of them along that path, and we can prevent 9 of them. We can say we're about 64% in terms of defense and death. Not too bad. And that can help us drive some decisions. Do we need to add more? Are we okay? Maybe this isn't going to happen very often, so we're fine, or maybe this is something that happens all the time, so we need to make some investments. So that's how we would do perimeter breach, using something like a postmortem off of a real-world attack, and looking at things like business objectives, payment processor, obviously pretty important to protect payment information. Attackers' objectives, obviously there's a lot of money to be gained by stealing those files. And some of the lessons learned in this one is, keep those controls broadly defined. We have the tactics broadly defined, let's have the controls broadly defined as well. And let's find ways to measure defense and depth and act appropriately. Now, on the controls, we tend to think about this in terms of elevating from tools, nouns, to tactics and verbs. In terms of security community, we're very good and very focused often on the tools, on the nouns. And we're so good. I'll give you an example of how good we are. I mean, with 24 hours, we could stop world catastrophes. I'll show you how this works. I'm sorry, I got to use Snowden. Apologies up front. But Snowden used wget. You guys hear about this earlier this year? He used wget to take the files, ostensibly. And within 24 hours, vendors all over the world clamored to stop Snowden, such as this vendor that helpfully released a signature to stop wget. The Snowden rule, right? The comment from the distinguished gentleman was, oh dear God. Yes, so we can stop wget, which is fantastic. We have stopped the tool of mass destruction. Unless you know anything about security, in which case you know that wget, you can override the user agents, it doesn't really work, or you may know that you could use curl, or you may be a Windows guy and go, what is all this crazy stuff? I've got PowerShell. The bottom line is tools, nouns don't work because the minute we create a signature or a way to stop that tool, that noun, the attacker changes. Right? This is the nature of the game we play. It's much better, we find, to elevate those discussions up to tactics, to elevate those discussions up to verbs. People who download files are going to download files no matter what they use. How can we stop them regardless of the tools? Any questions on that one before I move to pen tests? Okay. Yes?
How does W get rate on a scale of completely, insecure to bash attack?
So when you're comparing the bash attack to wget, there's a cat joke in there, isn't there? You're setting me up for a cat joke. Moving on. All right, so let's talk about a pen test. This is how we can take some common occurrences off the shelf and walk into any organization and say, here's how we stop an insider threat, here's how we stop malware. This is how we can look at the last breach you guys have had and model that. Let's talk about a pen test. When we do a pen test, oftentimes you're going to have retests, right? When you do a pen test, oftentimes you're going to have findings. I want to walk you guys through a pen test and show you how that modeled. So here we have a fantastic organization that has a guest Wi-Fi with DNS, right? Because you're on the Wi-Fi, you need DNS. A fantastic next-gen firewall, Blinky box with data loss prevention, and some great files back here that have payment information, credit applications that we don't want anyone to get to. Our pen tester is camped out on the guest Wi-Fi. And checking out that guest Wi-Fi, he realizes that that DNS server is not just only a DNS server, it's also a domain controller. Sweet. He also realizes that the NAT that IT operations did was not just for the DNS port, but was for the IP address. Sweet. By binding to that domain controller, our illustrious pen tester pulls down all the end users and begins to try to log in to an RDP box that's also on the guest Wi-Fi that was not in the original spec or in the original scope. Documentation that's incomplete in IT, that doesn't happen. This was clearly rare. By logging into the RDP box, finds a admin hash, passes that hash over to the file server, logs in, grabs all the files. But wait, what about that DLP? We print them to a PDF and we exfiltrate them through the DLP, which does not check PDF images. There's a scenario, very real world case, again, hypothetical, but we can break that down into things like crack the Wi-Fi, connect to the Wi-Fi, connect to the DC, bind anonymously. And with each one of these things, we can then walk through people on a tabletop exercise and begin to build our controls. And these controls can then form our punch list that we give to the IT folks post-pen test. Our punch list that our IT folks can then go ahead and evaluate and see, have all these things been taken care of? And we can see how many of them we can get coverage on, right? Maybe we can detect all 9, maybe we can prevent all 8, and they can start working on that and strengthen their defense as opposed to just having a narrative or a great document that has a fantastic Nessus results. Not that that ever happens. Oh, one thing about defense in depth I want to mention is this is control coverage, right? This is how much of that path we've got covered as opposed to defense effectiveness. This is another thing worth thinking about. So if you do have, maybe we've got 189% on prevention. You're like, yeah, more than 100. But we got to realize too that all those preventative controls only work like half the time, like DLP, for example, antivirus, all those type of things. So we want to have a lot of prevention, a lot of opportunities to step and catch the attacker along that path. But it is effectively control coverage, not defense effectiveness. So that's how we take a pen test, we make actionable items for a retest, and we use it as an opportunity to educate the IT ops people. Before being with VialPoint, I was a DevOps manager and security officer for many years, and I can attest to this very clearly, because I look back at many of the things I said and I kind of wince. But when you're in-house IT, you're like, we've got defense in depth. I know we do. Bob was up all night patching. We got fantastic defense in depth. I know because Jane just did something with the Cisco, and there's echoes involved. It's very difficult when you're an IT person to really know what those attacks look like. It's very difficult when you're in-house IT to really know how a pen tester moves throughout the networks. And this provides a fantastic opportunity to have those educational conversations with the IT guys. All right, questions on post-breach before I go to the next one? Except for about the bash attack. Yes, sir.
Real quick question. You mentioned the control coverage.
Yeah.
And you were talking about go back one more slide.
Okay.
That one right there. And you were detect 100% prevents. How
Right.
Do you weight them at all in that respect?
You absolutely could. You could weight them because of the effectiveness. If you wanted to, it's just another column in Excel, right? Easy enough to do. We don't, because the argument that I then see, it's the minute versus hour thing, right? So, well, my DLP is 100% effective. That's what my vendor says. Well, most DLPs are 70. Well, mine blinks twice as fast as theirs. So you could, right? It's just one more column that you would add in here and you do those weights. Another weighting we played around with is for the stages of attack. You should have better controls closer to the objective, right? So there's weighting you could do there as well. Anyone else? Yes, sir.
When you're looking at multiple attack vectors, do you focus on things that overlap?
So when you're looking at multiple attack vectors, do you focus on things that overlap? We do one of two different things. Either if they're different enough, we would do two different attack paths. If they're similar enough, we would have a branch, like lateral breach 1, lateral breach 2, within the same model. It works. Again, it's not a tree. I get it. Okay, so the next one we're going to do threat model is Dave Kennedy. Specifically, awkward hooks. No, I'm joking. But this was kind of interesting to me. One of our clients came to us and they're like, look, we are doing System Center Configuration Manager. And I was kind of concerned because I hear that there's this attack on it. And did anyone see Dave Kennedy's talk at DEF CON about this? Awesome talk. And in it, this is the very scene. He's like, lights the lighter, and he hits the button, and all of a sudden, like 1,000 different hosts get popped all at once. And our client's like, that sounds bad? Can we threat model that? I'm like, yes, we can. So very simple, right? You got your management computer that talks to your management server, and that management server can push out updates to servers and desktops. What Dave Kennedy's attack looks like is another phishing attempt onto that management computer. From there, updating repos on the System Center Configuration Management, and then initiating a refresh so the servers and the workstations see it as a new package. And then they all download that package and execute it. And of course, that's not really the package, it's now a malicious package with a malicious payload. So we went ahead and threat modeled that. Very simple again. Does the organization run System Center? Is there social recon on the admins? Phishing, PDF, enumerate the server location, locate the source package, upload your shell, go. Force a refresh, and now you own all computers. So we did a tabletop on this, and I think, again, this highlights very clearly the problem I had when I was an in-house IT guy. Because the first one of the controls that was at the top, we like to start at the bottom, but it was at the top, was determine if the organization runs System Center. And we had the table, per your recommendation. And at the end of the table, the lovely young lady sat, and she said to me, our stakeholder, and she goes, I want to stop you right there. There is no way that people are going to know we run System Center. And so I had the projector. I'm like, really? Okay, open up Chrome. System Center, company name, enter. 4 pages pop up. 1, a comment that the admin made on a blog. Okay. 2, LinkedIn. Guess what? Your admin's talking about he knows System Center. There's a 3rd one. And then the 4th, the creme de la creme, there was a case study made by Microsoft for this company about the beauty of System Center and all the values they're going to get. And our stakeholder looked something like this. And the rest of that meeting went very, very well. These threat models are educational tools. These threat models are discussion vehicles that we can begin to communicate. Because, again, people don't think about these things if you're in an IT role. Who's going to know how you run System Center? That makes perfect sense if you haven't Googled it. So here we took something Dave Kennedy did, but really any conference, right? Here today, and yesterday, there's been lots of talks on attacks. Any one of these can be modeled. Any one of these can be communicated to organizations specifically when they're about to install that technology and hitting them at the right time so that we can implement the right controls and allowing us to create actionable items for those IT teams so we can do the right things. I think in general, because we deal with a lot of technical debt, we deal with a lot of legacy stuff, most of our security controls look like something like this, right? I got my house, I need a wheelchair ramp, I'll just build one. If we get ahead, if we do the threat modeling as part of the build process, this is what Stride preaches all the time, right? You build it, you threat model it, or you plan it, you threat model it, you build it. Our controls don't look like this, our controls look like this, right? This is a staircase with a built-in wheelchair ramp. It's completely integrated. It's a beautiful structure, and it's a beautiful example of planning things out and taking into account all the different variables ahead of time. And I would argue if you do the threat modeling ahead of time, we can have more structures that look like this and less that look like that. All right. Any questions on that before I get to security exercises? Right. The question is, how can you iterate and implement threat modeling where you're doing shorter sprints, like in a Scrum environment, an Agile environment. So Stride, that's very difficult because you've got to threat model every single feature. If you're doing threat modeling at the application level or the system level, where you're open enough to say they would pivot this way, they pivot that way, they attack your computer, they attack this, you don't necessarily need to look at every single function and feature. So you could do it on a monthly basis. You could have like 5 different features come through and then look at the entire threat model of that system. This also elevates it out of just looking at code at that point to looking at the overall system. So there's this conference called B-Side Chicago. There's another conference called B-Side Detroit. And there's a CTF, and I've been giving this talk about SDL and hostile environments on this. Because what happened last year at B-Side Chicago is we had built this entire CTF framework, and it got attacked, right? We had threat models, we had everything in place, but it got attacked after the event, and some people got on and did some weird stuff, and we patched it. But what broke down there was not the security controls of the software. What broke down there was the system controls, right? There's weaknesses in Linux, and it was on Amazon. There's all these other things that are not encapsulated in a Stride model or encapsulated in a feature of an app. So by expanding and reframing it, and then looking at it holistically, you can slow down and account for the pace of changes in the application. Make sense? Anyone? Anything else? Yes, sir.
If we don't, we're up there, get out top, and we do Stride, so we just move into the quarterly planning cycle. In high level, so level 0, maybe a level 1, based off the features, and then say go for it.
Sweet. So, perfect. Okay, next thing, security exercise. So now we've got an attack. We've got a way to communicate with the IT people what that attack looks like and what controls we have. And the way for the IT team to communicate back to us what technology they have in place. The next thing is, how do we exercise that? How do we make sure that we're prepared for that? And I love Makerspace, Maker Faire, you guys seen this? Yeah, I love this, the life-size mousetrap. The ball, it falls, and then the bathtub flips. It's great. That's what I like to think of every time I do a security exercise. I'm like, yeah, I did it again, and they all look at me like I'm out of my mind. That's okay. Right, yeah. As long as it keeps going. Directionally accurate, that's what's important. But controls are pretty interesting. For example, you may be told we got fantastic physical controls, and we've got locked doors. Until you do an exercise and you recognize that fantastic locked door has the code key printed on the bottom of it. It's the same as your luggage. How did they know? Well played, sir. So these are real pictures. My favorite recently happened where they're like, the security team tells us, we take privacy very importantly, and because of regulatory compliance, we encrypt all our laptops with BitLocker with 256 AES encryption, and it's on everything. Like, awesome, that's really great. So we're walking around, and the developer says, yeah, if you ever need to use my box, see this piece of paper right here? Just type that code in. I don't know why the security team makes us do that, but that's how you boot the system. Really, guys? Controls are awesome, especially when our IT team tells us they have them, especially when our security team tells us they have them. No control is really there until we test it, right? No control is really present until we exercise it. And moreover, if we can come up with ways as part of this threat modeling exercise to make these exercises very simple, very easy to do, We can do it more often. If we can do it more often, we can have better levels of assurance. We can get stronger. We can have better incident response. So that's what I'm going to talk about next. And I already talked about Snowden, and you guys didn't boo me off stage, so I think that allows me to talk about Target. Sorry. Drink. All right, I want to recap the Target story real quickly, and then I want to show how this will look in a security exercise. A lot of you guys probably already know, right? Target's been beaten to death, but we had a lot of fun threat modeling it because a lot of people ask us about it and continue to ask us about it. At a high level, we had attackers that stole creds from HVAC and refrigeration company. Using those credentials, they connected to a billing system, which is a website. That billing system allowed them to pivot onto the network. Using that pivot, they connected to the store's general IT network. On that IT network, they found IT management software. Wonderful. That IT management software had default credentials. Wonderful. Those default credentials allowed the attacker to push updates because PCI environment is scoped, right? We only scope the secure PCI network. But of course, we have to manage it, which means we punch holes to the management server, which is running the default credentials. Using that IT management software, they pushed out point-of-sale malware. That malware scrapes the RAM, gets the card detail, packages it up, sends it back to the management server, which is pretty much the only thing that the POS can talk to. It gets compressed into about 11 gigs worth of data, pretty sizable number, which gets FTP'd back to the attackers. Let's talk a little bit about the tactics in this attack. And I want to, again, talk about making things high level and framing. The first one is, I mentioned they connected to the HVAC vendor. They spearfished the HVAC vendor. The minute I frame a conversation with anybody, that frame persists over the length of that conversation, right? More so, too, with your stakeholders, with management, with C-level. It's very important that we frame, when we do these models, things not as the HVAC vendor, because any manager worth their salt is going to say, we don't have an HVAC vendor, we're safe. Cut costs. But rather third party, right? Our third party vendor resources. Business partners, even better. Same thing with the billing site. If I say they connect to the billing site, they're going to say, Wolf, we'll secure that billing site. But there's a whole bunch of websites all over the place for our business partners that people are going to attack. We got to move the frame up. Same thing with the management software. Perfect example, right? If I say to anyone, they use blah, blah, blah software. They're going to go, we don't use blah, blah, blah software. We're safe. Good job. Did you change the default password? Oh, I was supposed to do that? Yeah. So then we go ahead and model this out. Now this model is kind of hard to see, I understand. But you see these highlighted things in yellow I'm going to talk about in a minute. This is what I think was the control structure for Target based on what I've read. They were able to detect and alert on malicious activity with a WAF. Vendor, not going to really mention, and they're able to detect the malware in the point-of-sale system. But every single point down this, they didn't alert on unusual activity, they didn't require 2FA for web resources, every single point down, they didn't have controls. These are IDs and IPs, which when we do the model stands for ideal detection, ideal prevention. Love Excel. Does conditional formatting. You do ideal detection, ideal prevention. It highlights it in yellow. I'm like, here, take the yellow, fix the yellow, and they fix it. See? Now, if it did pivot tables, it'd be even better. We should talk. You need to give me some advice. So this ideal detection, ideal prevention is key because this is what allows us to begin to build a punch list that begins the remediation plan. And it's just some high-level improvements would be things like, hey, why don't you do 2FA for all your business partners, right? You should be using something like Duo to get that done. Why aren't you alerting on network scanning? All these types of things. Again, moving the discussion and framing it one level up. Again, making controls that are one level up and are broad enough. And again, looking at each one of these controls as being one indicator of compromise. You get a couple of them, that starts your investigation. That's how you find and stop these bad guys. Now, they may come back and say, yeah, but Wolf, we had great network segmentation, which is awesome. That's a great response, because that then becomes our first exercise. What controls do you have? And if you're really proud of them and you think they're really strong, can we test them? So that's media, that's breach disclosures. Another source is leveraging the fear and concern that everyone has whenever these things happen, and then modeling out and figuring out what our response should be. Some of the lessons learned there is learn from other organizations, people getting popped all the other time. The other threat model talk that we had today was awesome because they're like, hey, here's some news articles, threat model them. That's great. Let's pick those articles apart and build a threat models and see what that would look like in our environment. And then let's build exercises to test the various controls that we think we have, and then figure out how we can get the controls we need. Whenever I talk about this, invariably, especially on Twitter, not in person, but it's Twitter, people go, well, you're using FUD. We're not going to threat model because it'll scare people. People are already scared, right? Organizations everywhere, if they're paying attention, are already scared. If we use threat modeling, or whatever vehicle you guys choose, but if we use threat modeling to assess our controls and to clear up the uncertainty and point directionally what controls we need to implement and how we can make things better, or even better to say, look guys, you guys are awesome. This organization just got breached this way and you guys don't have this problem. That's not FUD. That's the exact opposite, right? That's doing good diligence as security professionals. Any questions on that one before I move forward? Awesome. All right, a little bit more on exercises. So let's look at the other models we looked at and just show what some of those exercises will look like. So in the common malware, we had things like block attachments at the gateway. An exercise would be send an email attachment. We have things like the malware creates local admin accounts. Create a local admin account. The malware is modifying files. Modify a file. Do we detect it? Can we prevent it? Are the right controls in place? Or is there a door that's locked with the sticker on it? Insider threat, same thing, right? We look at things like, hey, logging into disabled accounts, good one. So we'll ask the admin, hey, can you log into a disabled account? And we'll see what that looks like in our IPS, our IDS, our SIM. Pen tests, you can take the exact same pen test we looked at, and we can make an exercise for each one of them. Right? Audit the Wi-Fi coverage, connect to the guest Wi-Fi and see if you can get to the DC, connect to Active Directory using PowerShell and see if you can enumerate user accounts. Each one of these things, right? Log in over RDP, copy files, FTP files. Each one of these things, if you think about it, are effectively IT work. This is a model made for security operations and for IT operations. None of these exercises are going to say, you should go out and buy core, you should get your guys an OSCP, and you should have them spend at least 1 week banging on your production servers. Because any CIO worth his salt is going to go, that's a lot of money, that's a lot of risk, and we're not doing it. And we can use these models as exercises and build them as IT work that does not introduce the risk of a pen test, but rather simply reproduces the evidence of a pen test. We can then do it much more frequently. We can do it during production hours. We can hand it off to our IT team. They can get it done. Because, like we like to say, you know, when work looks like work gets done. It's an Excel file. People will do it. If it's creating an admin account, my IT guy already knows how to do that. We don't need to be trained. It can then be executed on a regular basis. And what's also nice is, we started to see this with a couple people in MySec, is these tests can then be created as run books in your orchestration, because standard IT stuff. So if I got a run book, and I can run it every quarter and see what I'm at, or every month, or every week, that test is now automated, and we can see and keep our finger on the pulse as things change. The caution here is we don't want to teach to the test, right? We don't want to make people think that just because they pass the test, everything's fine. It's an ongoing process. Attackers will do what attackers do. It is what it is. But once you have these exercises, we can then do the next thing, which is instant response drills. We can race the clock. We can see how effective we are. And we can see how great our IT people are and our security people are at responding to these threats. This was one of the questions I was talking to Leslie about in her talk is, how do you actually build your security controls so that you can run them as an exercise and see how good you are? We take those exercises, we run them, we measure the time to respond. And that's the other lesson learned here from this part, which is execute them regularly to determine the efficacy of the controls, and execute them regularly to determine the response, right? Are we within, we said we'd do it in an hour, do we catch it in an hour? Or do we not see it at all? We can do these full knowledge, everyone comes in one room, we do it, and we say, hey, did you see that? Yeah, I did. Or we can do them blind, right? We don't tell these security operations people, see what they detect. And that keeps people on the toes, keeps people tight, and keeps people prepared to respond when these things happen. All right, so I'm going to wrap up. I'm going to do conclusion here. So you guys may be wondering when you walked in this talk, what's threat modeling, what's attack paths? Like Jimmy Vo, you may have asked, is that where I pose shirtless with an AR-15? Because let's face it, that is a threat that's been modeled. Thank you, Jimmy Vo. If you guys don't know, by contract, when Jimmy Vo joined my team, I'm required to put at least one picture of him in every slide deck. He gets to twerk once a month and roundhouse every client that gets out of line. It's and all green M&Ms. I'm pen testing. I need all green M&Ms. Very, very talent these days. No, but so threat modeling is all about understanding, right? Understanding what a real attack looks like and understanding the context of things like Heartbleed and the latest breach of Target and Snowden and all these types of things. I think Jeremy said it best, and I'm going to steal his tweet. I don't have a picture of you without your shirt on, though. I'm sorry. That's in my other deck. It's like when I see these articles, right, these articles about the latest and greatest breach, it's like I'm not thinking like attack paths and threat models, mitigating controls, and all the things that we should be thinking about, all the things we should be communicating about when people are coming to us and they're concerned about how we're going to respond in our organizations. This is a great way to educate, right? Educate the IT folks. I can guarantee you with these organizations, there are people who care about their environment, right? There are people who invested time, blood, sweat, and tears. There are people who are sure that they've got defense in depth. There are people whose job is on the line to build and maintain this infrastructure. We need a better way to communicate to them where their gaps are, as opposed to saying, you need a next-gen firewall, you need a WAF, you need a DLP. And we find that threat modeling within MySec is a very good way of doing that. It allows us to tell where our defense in depth is adequate for the task, and perhaps where it's not. It's a great way to improve security controls, especially as part of the build process, so we can have more controls that look like that, are integrated, are nice and neat, are keeping up with the design, and are being built into the system. It's work that looks like work. It's work that gets done. It's not something that's tacked on after the fact. And once it's built, it's a great way to evaluate, to get out the mousetrap, to run the game, and make sure that those controls are actually working as advertised. We can exercise, we can run, we can race against the clock, and make sure that we come in on time, and that we're building up our incident response muscle by running these exercises over and over again. Okay? That's been the MySec attack path. I'm going to put my contact information up if anyone wants more information. We're working on a white paper. We're going to be publishing it here pretty soon. And I am completely out of time, but if anyone has any questions, they can see me afterwards. I'll be here tomorrow. All right? Thank you all. Hope you have a great night. See some of you at the after party.